Cox Comb chart, also known as a rose diagram, which is a variation of a pie chart. This chart was initially designed by Florence Nightingale in 1858. In this Cox Comb chart, each category is represented by a section of a disk, and each section has the same angle. The area of a section represents the value of the corresponding category. And in this particular tutorial, I'm going to share with you how to create a Cox Comb chart in Tableau. So without any further ado, let's jump straight into it. Welcome back, this is Gurpreet, and in today's tutorial I'm going to talk about how to create a Cox Comb chart in Tableau. Well, for this particular chart we'll be using bins and data densification technique. But first of all, let's understand what is this Cox Comb chart. Well, it is a variation of a pie chart on a circle where each of these disks, or you can say a section of a circle, it represents a category or a dimension in Tableau's term. And the area of this entire section represents the value of the category. So in this particular example, I am using the sales by category. So the entire area of this section represents the sale, and each of this section represents the month, and different color coding represents the category in this particular scenario. So for example, if we need to plot 12 different months, then each segment will represent a month. So this particular slice or a segment is representing 1 month in this case. And as I mentioned earlier, we can further divide these segments into multiple values by bringing the color legend of another dimension. And in this case, I have included categories as another dimension where I have splitted this disk or section into 3 different parts based on the sales. So if I hover over to this one, this particular section in red color, it represents the sales of furniture in the month of March, which is $80,000. And if I hover over to this yellow section, it represents the technology sales, which is $10,000 for the same month. And then this blue section represents the sales of office supplies, which is $7,998. So let's now look at these individual segments and understand how these charts are built and the mathematics behind these charts. So each of these segments are around a point, so the angle for each segment is same. So in this particular case, we have 9 different segments, as you can see highlighted here, and these 9 segments represents 9 months. So the entire angle around a point is 360 degrees, and in this case we have n as 9 segments, so the angle for each of these segments is 40 degrees. So as I mentioned earlier, in Cox Comb chart, each segment represents a different dimension and the angle of each segment is same. So in this case, the angle is 40 degrees for each of these segments. And let's now look into further details by checking how each individual segment will look like. So in this case, I have taken a slice of segment 8, and this segment is further divided into different points, artificially generated points, which technique is known as data densification. And for this, I am using the bins. So I have plotted 200 points between this arc, on the arc between these 2 points, and which means that there are 200 separate sections created between these 2 points. So once we understand this section, then we simply need to understand how to calculate the radius of the segment using area of the circle, and also we need to create the angles between each of these segments or each of these segments using bins. Once we have the angle and the radius calculated using mathematical formulas, then we need to calculate the x and y coordinates to actually plot the points to create this chart. So for that, we will be using a data set which will look something like this, where we have the countries, sale types. So in this case, these are the categories: office supplies, technologies, and furniture, and the date of the sale and the sale values. So this is what we are representing on the Cox Comb chart. And also for data densification, I have created a path field which is from 1 to 200. So we'll be creating the path field to create those artificially generated points, which is called bins. So now let's see how we can create this chart in Tableau. For this, we'll be connecting to this particular data set, so the Excel spreadsheet, which I have connected it here. So I will be bringing the data set, the Coxcomb data set, which is nothing but the country, sales type, date, and sales field. And also, in order to create the data densification, so I will bring the data densification table, which has points between 1 and 200. So I will bring that densification table and leave it here, and I will then create a cross join by simply creating values. In this case, I will create a join calculation by putting 1 in there, and same way I will do it for the densification table and put 1 in there. So this will create a cross join. By that I mean is for every row in the Coxcomb data set, I will have one additional row which will show the value of path as 1 and the original one as 200. So between these two rows, we'll be artificially creating points between 1 and 200. So once we have created this data set, we will go to Sheets. And here, the first thing we need to create is create the path bin. By right-clicking on the path, and we go to Create and Create a bin. And in this case, we will create the size of the bin as 1. And you will see here, the points between 1 and 200 is 199. And that's the difference, and the count distinct is 2, basically 1 and 200. So it's giving the value of count distinct at 2. So what this basically means is we are artificially creating 199 points between 1 and 200. So click OK. Once we have created this field, we will be then creating few other calculations. So in this case, I have already created these calculations, so I will show you one by one what it means. So the first calculation is the index calculation. So in this case, we are creating the index calculation, which will help us to return a row value in a partition. And we will be using this for partitioning the values in the bin. So as I mentioned earlier, so in an example where I have shown you the diagram in the circle. So in one segment, we have artificially created multiple points. So we have created from 1 to 200. So all those points here needs to be indexed in this partition. So from 1 to 200. So that's what we are using index calculation for, where we can create the partition from 1 to 200 for that bin values. So after that, we will create another calculation called count, and that's again an index calculation. But this time it will return the rows in the partition for the segments. So in this example, we have 9 segments. If we see here, so from 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 9 segments represents the 9 month. And we need to create an index calculation to partition those values into 9 segments. So that's why we have created another count or index calculation, which is called count, to partition by segment. So one is for these 9 segments, the other one is for partitioning the values in using the bin. So once we have created these two index calculation, then we will create number of segment calculation. So this number of segment calculation will provide us the number of segments. So in this case, we are saying Windows max for the count, and this count is basically calculated using the month of month of the date. So also we can use it in the default table calculation. We can go here and compute using, we can say, date. And we want month of the date. So that's how we are doing the partitioning of this index value. We can do this value here as well, and I will also show you another way how we can set the compute using in the edit table calculation as well. So once this is created, then the next calculation we need to create is angle. So this angle calculation is really important because this helps us to determine the starting angle of the segment. By that I mean is, if we look at this chart again, so each segment is starting at a different point, right? So for example, segment 9 is starting at this angle. And if we look at segment 3, it's starting at this angle. So this angle calculation determines where that segment is starting. So basically this is the index calculation where it talks about, like, if we are talking about the first segment, so 1 minus 1 is 0. So it is starting at 0 degrees. So that's the first segment. So if we look at again this calculation, so the first segment is starting at that 0 degree. So it's starting from here. And then the second segment is starting at this particular value, right? So we are just saying 2 pi is basically 180 degree, right? So 2 pi divided by number of segments. So in this case, we have 9 segments. So we are saying, so 1 minus 1, 0 into 2 pi divided by 9. So it is basically 20 degrees. So the second segment will be starting at 20 degrees, then 40 degrees, then 60 degrees. So that way we are starting all the segments in 180 degree section. But right now we are using 360 degrees. So basically it's all then multiplied by 2 to give us that angle, which is 40 degrees. So each of these segments are then starting at 40 degree. So it started 40 degree here, 40 here, 40 here, 40 here. And for all the 9 segments, it's 360, right? So that's how it will work. So now let's go back to the calculation here. And let's show it here again. So 2 into 22 by 7 divided by 9. So that's how these calculations will work. So that's about angle calculation. Now after that, let's go to radius calculation. And radius calculation again, so if we look at the diagram again, so our area is pi r square for the circle, but we are only interested in this arc, right? So the radius will be area divided by pi and square root of that. And in this case, the area represents the sum of sails. So for that, we will look into this calculation where we are saying square root of sum of sails divided by pi. So this will help us to calculate the radius. So now we have all the radius, we need sum of sails as well, where we are just saying for that particular segment we are using Windows Max, so that will give us the maximum value of that particular segment, and then we are saying sum of sails. So in that particular segment we are getting the sum of sails. Now let's calculate the coordinates for x and y axis, and before that let's understand the concept of how to calculate the coordinates. So in a circle, let's say we have a origin as h and k, and where the value of x and y coordinate on the circumference is x and y. And we have the radius as a hypotenuse, in this case as r, and y as a perpendicular, and x is x-axis. So the equation of circle is x minus h square plus y minus k square equal to r square, where h and k is the radius. But in this particular scenario, we are considering h and k as an origin, which is 0 and 0. So in that case, we are saying, so if this is the angle theta, so sine of theta is equal to O divided by h, which in this case is y-axis, y value, and radius. So sine theta equal to y upon r, so y equal to r sine theta, and similarly x is equal to r cos theta. So we will be using these two values to calculate x and y coordinates. So now let's see how we can do that. So in the x-axis, we are saying if index equal to 1 or index equal to Windows maximum value, which is 200 in this case. So for index 1 or 200, we are saying the x-axis or the x value is 0, because we are only interested in calculating the coordinates for all the points between 1 and 200. So we want to calculate the coordinates of these points. So that's why we have kept the coordinates for 1 and 200 point as 0. So now let's go back to the sheet here, and we will see. So in that case it's 0. Otherwise we want radius, which is window max, and we are getting the radius. So for that particular segment, maximum value of the radius into cos of theta. So in this case, cos of theta is, so this entire thing is theta, and which comprised of multiple sections. So the angle section means the starting point of the angle of the segment, which is from which angle the segment is starting. And then we have index minus 2 value, so which means that we are only interested in the angles between those 200 points between 1 and 200, which is 200 minus 2 value. So those are the angles we are interested in. So that's why we have used this value. And then we are saying the angle of the segment, which is window max into 2 pi divided by number of segments. So if we are saying we have 360 degree as an angle, and then we have number of segment as 9, so we divided it by number of segments, so we got the angle of this particular segment. And then this angle, we are also dividing it into 200 parts. In this case it's 199, because 200 minus 1 equal to 199, so that's why we need the angle for all those 199 parts. So that will be our angle, so the small individual angle. So that's how we created x-axis, and similarly we have created y-axis. Same logic, but we have changed our sine theta for y-axis. Once we created that, we will simply use these calculations to create this chart. So let's see how we can do that. So now let's create the dashboard by first bringing the path win value into the row shelf, and we will make sure by clicking on this that all the missing values are shown. So you will see here from 1 to 200 all the values are shown here. Then we will change the mark type to polygon and drag the path win into path marks. And then we will bring the date into the detail mark, and we will change it into month because we want to see all the segments by month. And then we will bring the sale type into color, where we want to see all the furniture, office supplies, and technology separated in one segment. So once we have that, we will move this month type just above the sale type, and then we will bring x-axis into column shelf and y-axis into row shelf. And also we will bring the country into the filter selection area, where we will select one of them, let's say Japan in this case, and then we will select this drop down and go to edit table calculation. So this is another section where we can select the values, how we want to compute these calculations. So in this case, let's start with x-axis, where I want to compute x-axis value by path win. Then I will go to the nested calculation and select index, which again I want to compute it using path win. And then we will use the count. So before I do that, so index values, which we were saying like in our previous example where we looked at these values. So the index calculation which we created is doing the partitioning by the values in these bins, right? and the count calculation which we created, which is again the index calculation, but it is used to do the partitioning by the segments. So that's what I'm doing here. So for index, I'm saying compute by using path bin, and for count, I will say compute by using month of the date. And for number of segment, I want to do it by month of the date and by path of the bin. So once this is done, close it. Then we do the same thing for y-axis. And I will start with y-axis. I want to do it by path of the bin. Then index, I will do it for path of the bin as well. And then count, I will do it by month of the date. And you will see it started to appear here. And then the last one, we need number of segment, which I want month of the date and by path. Once you do that, close this popped up window and you will see the chart is created here. But again, here we have few other things. So I will bring sum of sales into the tooltip, and I will say compute using path bin. And I want to sort the sales type by field, which in this case I will use sales and sum of sales. Once you do that, you will see here each of these segments are now sorted based on the sales. So let's now do the formatting. So here I don't want path bin, and I don't want x and y axis, and I will just say sales type. So for sales type, I am showing the sales value. Sales value along the path here. So once I do that and click on this, you will see for the month of May, the furniture sale is 77 grand. And for the same month, technology is 12 grand and office supplies is 10 grand. So you can do a bit more formatting here by changing the borders. We don't need grid lines, and we don't need zero axis, and we can hide the headers. And also we can format it and change the worksheet to black if we want. And we can do the axis formatting. And we can also change the colors if we like to. So we can select any of the dark colors. In this case, if we want to select this one, and let's say this one. So you can change the colors, and you can also add the borders if you like. And here you go. So your Cox Comb chart is created. I hope you guys like this session, and if you have any questions, please feel free to reach out, and I will try to get back to you as soon as possible. Thank you so much, and see you next time.